Hello everybody, and welcome to the Front Room. I'm your host, Nathan Rigoni. In this series, we're going to cover some of the basics of artificial intelligence and machine learning. The point of this series is to introduce most of you to the concepts that make up the basis of many of the technologies that exist in AI today. Break those technologies down into their components, and I'll try to explain from the beginning how we got here, what we use, and why. This should also help you understand what the concepts are, the limitations of AI, and what the future may hold for this technology in its use cases in industry. In each episode, we will choose one topic and we will break it down. I'm hoping to keep the episodes to less than 15 minutes. I hope that these episodes help, and I hope that you enjoy them. Today's topic is image processing. We're going to talk about how neural networks perceive images and are capable of doing things that even the human mind cannot. Okay, let's jump into it. Okay, I'd like to start this talk with a definition. So the star of the show for image processing is a thing called the convolutional neural network, or the convolutional layer. The convolutional layer is actually a replication of a process that we used to do on images before neural networks. And it was a way of essentially compressing images into smaller sizes and then being able to decompress them using a mathematical formula. But before we even get into that and talk about the star, first, we want to figure out what even is an image. So an image, as it turns out, even before we were digitizing everything, is essentially just a matrix or a square or rectangle of a bunch of different points that are different colors. And if you kind of zoom out from all of these individual points that are each their own individual color, what happens is it makes up an image. Your mind perceives the light that's coming from these pixels or these individual dots of color, and it is capable of turning that into a shape or a form. And you understand it as a dog or a cat or whatever the picture is of. So breaking that down even further, when we get into the digital realm, each one of these pixels is divided into what's called a channel. A single channel image would be something like black and white, or what we call grayscale. A 3-channel image, which is most of your color images that you see today, basically break their channels up into red, green, and blue. And you get values between 0 and 255 that represent how red, how green, and how blue that particular pixel is. And with this, we're capable of making ranges of colors by mixing and matching pixels together, and then mixing and matching their red, green, and blue values. So this is how pictures are made up. So unlike NLP, we actually have pictures kind of defined in a realm that is already numerical with our RGB channels and our ranges between 0 and 255. So how do we then take an image and turn it into something that machine learning can use to do a process? Well, we use this thing called a convolution. So what a convolution is it's a process by which we take a group of pixels, let's say in a 1024 by 1024 pixel image. We want to go through and group each group of pixels. Maybe there are 9 pixels where we take 3 across and 3 down. And we want to aggregate the values of the channels in those pixels in some way so that we can shrink the image from a 1024 by 1024 to something like a 256 by 256 pixel image. The reason we want to do that is because the neural network is going to have to process all of this data. And in order to do that, we actually want to do 2 things to this image so that the neural network can do a better job. One, we need to kind of get rid of a lot of the data that doesn't matter and make the image smaller so that the neural network can run faster, and so that the cognitive portions of the neural network that we're going to be training later will have much less data to have to sift through in order to make their decisions. The second reason we would want to do that is that noise removal part happens when we start to compress things. So, what we do in that convolution is we're actually compressing information by what's called a kernel, which is that 9 pixel square. It's a 3 by 3. We're compressing information by aggregating all those values. The easiest way to think about that is maybe we want to take the red, green, and blue values of those pixels and we want to average them so that we now have a single pixel that is the average of the red values, the average of the blue values, and the average of the green values. That's one way to think about it. There is a deeper part of a convolutional neural network where it is learning not necessarily the average of those things, but what we're doing is adding parameters to learn what the correct mathematical or the most optimal mathematical combination of those pixels are across that kernel in order to solve the machine learning process that or problem that we want to solve. But the point being is that the convolutional neural network is the way that we operate this. Training those convolutional neural networks to compress and then decompress data, much like we did with the autoencoder, is how we end up solving the problem. So, what I want you to think about anecdotally for this is don't think about like all of the math that's happening in the back end. Think about this. You're watching TV, right? And each one of those pixels on your TV, you may have like a 4K TV or something that's like high def. Each one of those pixels on the TV works just like it does in the image. It's a single color. But if you think about how much detail you can see when you sit closer to the TV versus how much detail you can see when you sit further away, let's make it a difference of, say, like 20 feet. There's a large difference between being closer versus being further away. This is very similar to what happens when we start to resize the image from a 1024 to a 256. Some things get a little bit blurrier to our perception, but what's happening underneath in the machine learning model is it's keeping the things that are most important through its learning of the correct weights and parameters in that convolutional neural network. It's keeping those things in focus. And it's getting rid of all of the other things that are not supposed to be in focus or are distracting from the true nature of the problem. So, some of the things that convolutional neural networks can learn is sometimes they learn to do things like edge detection, or they learn to do things like segmentation. These things are essentially learned by learning what kind of filter is necessary in order to preserve those details in that compressed image state. So, what might someone do with an image processing technique? Well, if you've ever used the feature in Instagram called remove background, that tool is essentially a segmentation tool. So what it's doing it's a pre-trained model that has been trained to detect the edge of, say, the focus of the photo, which might be a person, might be yourself, might be a dog, it might be something else that you took a picture of. But essentially, what it does is it detects the edge of that object, and it draws pixel by pixel a line around that object that captures the outline. And then it removes everything else that's not within the outline of that object. So if you use Instagram and you've used that tool, this is actually a tool that is a machine learning tool and kind of depicts the way that the AI learns how to do image processing. Other things that you can do with image processing, which push us towards more like video processing, is if we break down videos and think about what videos are made of, they're made of a series of images. So you take in, just like a flip book, you could take a set of images that you've taken in rapid succession and you can flip through them and see the progression of the states of the images over time, which is essentially what a video is and what each frame of a video represents. The same applications apply to video processing as apply to image processing. We just add one more dynamic feature to that landscape, which is over time. So, one of the things that convolutional neural networks can actually learn to do, if you add a little extra spice into your model, is you can do what's called next frame prediction, which is essentially training a model to take in one image and predict what the next image in the time series might look like. And this is how video generators are created. There are other methods, but that's the most basic idea of how to create a video generation model. So let's recap here. Essentially, what an image is it's broken down into sets of pixels, sometimes millions of pixels, that are all their own individual color. And the aggregation of these pixels at a far enough distance away lets you see sort of an image that pops out because of the contrast in color and the differences between pixels. Convolutional networks and convolutional neural networks take advantage of this by essentially learning and performing a mathematical function across these pixels in order to filter them into usable states that actually help the model predict a problem. A convolutional neural network and the applications of convolutional neural networks are how both image processing and video processing are performed. And so things like the background removal tool and video generation are built on top of the foundation of convolutional neural networks. Thank you for your time. Thank you for listening. I hope you enjoyed the episode. You've been listening to The Front Room. The Front Room is written, recorded, and produced by me, Nathan Rigoni. If you'd like to know more about what our company does and what it could possibly do for you, you can reach us at nathan.rigoni@phronesis-analytics.com. We'd like to thank you for listening and have a good day.